this one, let's take a look at finding an expression for cosine of a sum of two angles from the sine of two angles, the way you see it there, using differentiation. Is that possible somehow? So maybe you want to pause the video and think about a way of doing that. So here I have sine of x plus a, and then I have sine of x cosine of a, and then plus cosine x sine a. You should observe that in this context, a is essentially meant to be a constant, okay? And x is the variable. That's important. Why is that important? Because imagine what I want to derive somehow using differentiation as a rule for cosine of x plus a. Okay, so the cosine of a sum of two angles. I want some kind of a trig identity. That's my goal here, okay? So to do it through differentiation, I can use implicit differentiation on the original sine of x plus a equals that entire expression on the right side. Let's go through that process a little bit. So here, I'm going to work this out as follows. So I'm differentiating on the right side, or the left side rather, sine of x plus a. And on the right side, again, I'm going to differentiate with respect to x, so d dx, that entire expression, sine of x, like this. Sine of x, cosine of a, plus cosine of x, and then sine of a. Now again, remember in this context, so now let's differentiate the left side. So it's going to be cosine of x plus a. And here it's going to be times the derivative of the inside. You have to use the chain rule, okay? So, and then x plus a. And let's differentiate the right side. So how does that work here? Let's go through it carefully. So notice that first of all, on the right side, anything with an a is constant. So a is constant, which means cosine of a is constant, okay? A is constant, therefore sine of a is just a constant. I know it doesn't look like it, but it's just a number. Whereas sine of x and cosine x, well, x changes, which means sine x and cosine x also change. So x is the variable. So when I differentiate that side, it's going to look like the following. I'm going to put the cosine a on the outside. It's just a constant. And I'm going to multiply by the derivative with respect to x of sine of x, like that. Plus, again, I'm going to put the sine a on the outside. It's just a constant, sine of a. Multiply by the derivative of cosine of x this way. See? Let's simplify this a little bit. So now on the left side, you have cosine of x plus a times derivative of x plus a. So cosine of x plus a is already done. Not much else to be done. Now the derivative with respect to x of x plus a is just 1. Derivative of a, well, think about it. A is a constant. It doesn't change. Its derivative is 0. The derivative of x is 1. So if you wanted to be very formal, you could basically write something like this. 1 plus 0, okay? But most people wouldn't write that. They maybe write a 1, and not even that most of the time. You would basically just leave the expression as cosine of x plus a. That's it. Now on the right side, cosine of a, constant. The derivative with respect to x of the sine x part is cosine x. And then the derivative, again, beyond that, after the plus, that would look like plus sine a. Again, that's constant because a is constant. And the derivative with respect to x of cosine x is negative sine x. And now notice on the left side, when you clean this up a little bit, I'm going to have cosine of x plus a, which is what we've been looking for. Nice. Then cosine of x, if you like, you can write it that way, cosine of a. Again, the fact that I'm putting cosine x and followed by cosine a is not important. It can be switched. For the next one, usually you see that negative with the sign there. You're going to float that to the middle of that expression. So it's going to give you, for that reason over here, a negative. For example, sine x and then sine a. And notice that this is indeed the expression that represents the cosine of a sum of two angles, derived not using trig really, but calculus and implicit differentiation step by step. So if you like this kind of video on mathematics, please leave a like, please subscribe. Thank you so much for watching, and I'll see you in another video.